All right, Chapter 8, Test Review. So getting ready for the big test. You're going to notice some of the problems on this test. You don't have to solve every single one of them. Some of them I just want you to set it up because these problems take quite a long time, especially the law of sines and the law of cosines. So in order to get the test done in a decent amount of time, I'm not asking you to solve all of them. So some of the questions may be worded a little different, so it's nice we get to practice those on the review. So let's bust out 1 through 3. So looking at first thing I notice is we have a right triangle here. So since it's a right triangle, I know that I can use SOHCAHTOA. There's no reason to use law of sines or law of cosines. I'm just going to use the straight up SOHCAHTOA trig function. So in the beginning, tangent of R. So remember, R is my reference angle. This is the reference angle. It tells me where to stand. So I'm looking over here and I stand on R, or you put your guy on R, however you want to do it. Then I label the sides. So across from the 90 is always the hypotenuse. Across from the angle I'm on, that's the opposite. And the side closest to me is the adjacent. ADJ, not Y. So tangent, remember, is opposite. That's TOA. So tangent is opposite over adjacent. So the tangent of R, if I want opposite over adjacent, that looks like 12 over 5. So the correct answer for that one would be B. Number 2. Now notice things change a little bit. I'm going to go back here and I'm going to erase this because for number 2, I now have a different reference angle. My reference angle is now S. So this is my reference position. I need cosine. So cosine is adjacent over hypotenuse. So adjacent, so to this angle, this would be opposite. This would be adjacent. I shouldn't have erased hypotenuse because that never changes. It's always across from the 90, regardless of where you stand. So adjacent over hypotenuse, that would be 12 over 13. So that one is going to be C. So number 2 is C there. Looking through, number 3 says find the measure of angle R. So on angle R, whenever, anytime you want to find the measure of an angle, I know that I'm going to have to use the inverse to find angle measures. Alright, so I know I'm going to do that ahead of time. So I'm going to go back to my picture. I'm going to erase this stuff. And the measure of angle R, so here's my reference angle. Labeling my sides, I have opposite, I have adjacent, I have hypotenuse. Since I have all three, it's what I like to call a dealer's choice. So you can pretty much use any one you want. If you like sine, then the sine of R is going to be opposite over hypotenuse. If somebody else wanted to, they could do the cosine of R and do adjacent over hypotenuse. And still somebody else, if they wanted to, could do the tangent of R, which would be opposite over adjacent. Any one of those you could use to figure out what R is. So with all of them, I'm just going to do the inverse. So if I do this one, I'm going to have to do the inverse sine of 12 divided by 13. Or I could have did the inverse cosine, 5 divided by 13, or the inverse tan of 12 divided by 5. So it makes it nice when you have all three sides. You can choose any one you want. And regardless of which one you choose, the correct answer for all those should be D. Alright. For number 4, given the sine of A is, so this must be a different problem. Let me scroll down here and see what we got going on for 4. Alright, so given the sine of A is 5 over 13, which triangle is labeled correctly? Well, sine, remember, is opposite over hypotenuse. So basically it's saying when you stand on A, which one has an opposite of 5 and a hypotenuse of 13? Well, first of all, that has a hypotenuse of 13. This one has a hypotenuse of 13. This triangle does not have a hypotenuse, so it can't be C. This one does not, so it can't be D. So those two are out. I know it's either A or B. And if my reference angle is A, if I stand on A, this would be opposite, this would be hypotenuse, but that would be 12 over 13. So it can't be A. It looks like it must be this one, because opposite would be 5, hypotenuse is 13. So I believe for this one the correct answer would be B. Alright, so moving on down, number 5 and number 6. These are just calculator questions. So basically, I'm just going to punch these into the calculator, and the sine of 40 degrees is 0.64. If you're getting a different number, just make sure that you're in the right mode, that you are in degree mode. You do not want to be in radian mode. You will get all answers will be wrong. So don't be in radian mode, be in degree mode. For the inverse, you're usually going to, on most calculators, you're going to have to hit second and then cosine. Again, you know, by now you should know where all these keys are in your calculator, and this shouldn't be too much of an issue anymore. A lot of calculators have the little inverse right above the key. Other ones you have to go into a menu. But when I did this one, I got 55.2 degrees. Remember, anytime you need to find the number of degrees, you have to use the inverse. That's just the way that it's set up. So moving right down, use the triangle at the right for 7 and 8. Find the length of BC. So again, I look at the triangle first to see what type it is. It is a right triangle. So I know I can still use SOHCAHTOA. There's no need for the law of sines or the law of cosines yet. So BC is X. I'm going to stand on the angle that they give me. I'm going to label the sides that I have. This would be adjacent. This would be hypotenuse. I don't really even need to label the opposite over here because there's no value over there, so it doesn't help me. So I basically need to find the correct ratio that involves adjacent and hypotenuse. And that's that's cosine. So set this up. The cosine when standing on 37 degrees is adjacent over hypotenuse. The rule here is, well, there's one of two rules. One, you could just put a 1 underneath the cos of 37 and cross multiply. I know some of you like that method. The other way that you can do it is, if you remember, when x is high, you multiply. Basically, you're multiplying by 14. And 14 times the cosine of 37 degrees, when I did that, worked out to be pretty close to B. All right. Looking at number 8 here. Number 8's a little tricky, and this question was pulled off of an SAT test, or ACT test, I should say. Find the length of AB. So normally if I wanted to find the length of AB, which we'll just call Y here, I would stand on 37. So I'd put my guy here at 37. And since I don't know X right now, I would basically say, all right, the sine when standing at 37 degrees is Y over 14. And when I look through here, I don't see any of them that say sine 37 Y over 14. This one is close, but it's backwards. This one is the wrong, it's cosine. So both of my 37 degrees are out, and now I see a couple that say 53 degrees. Well, what that's referring to is we could calculate this other angle over here, 53 degrees, and instead of having our guy stand there, we could kind of put our guy over here and stand in this position. So now when I look at the two choices left, the sine of 53 is 4 over 14. Well, that can't be it because I don't even see a 4 on there. I believe it's going to be this one. When I look at C, the cosine when standing on 53 degrees would be adjacent over hypotenuse. Cosine is ca. And this is the adjacent, this is the hypotenuse. So that would allow me to find AB. That one was worded kind of weird, but we did see that in a standardized test, so we thought we would kind of present it in that way so that you wouldn't be shocked the first time you see it on a real standardized test. All right, number 9, find the perimeter. So the perimeter, remember, is I have to find all 3 sides. So I have to add all three sides. And they give me one of the sides. One of the sides is 14. So when I add up all three sides, the first one I already have. I just need to find the other two. So right away I know the answer can't be A, because that can't be all the sides added together because it's smaller than one of them. So let's go ahead and let's find X. So to find out what X is, if I put my guy here, this is going to be opposite over hypotenuse. So the sine when standing at 33 degrees is opposite over hypotenuse. So times both sides by 14. And 14 times the sine of 33 degrees. Let me just calculate this real quick. 14 times the sine 33. That is 7.62. So that's X. So let's just call it 7.6. So 7.6. And now I got to find another side. So I'm going to write that 7.6 up here. Now I want to find this side. Let's call it Y. So when standing here where my guy is, this is adjacent. So I think I'm going to now use cosine. The cosine of 33 degrees is Y over 14. Again, Y is high, so I multiply. And 14 times the cos of 33 is about 11.7. So now when I add up my three sides, 14 plus 7 plus 11.7, that comes out to be pretty doggone close to 33.3 inches. So that was a multi-step problem, pretty involved. Number 10, find the measure of the missing angle. Right there, man, light should be going off. Inverse. Got to use the inverse when you want to solve for angles. So we're trying to find this angle here. So I put my guy on the angle we're looking for. This would be the opposite. This would be the adjacent. That sounds like a tangent problem. The tangent when standing at I don't know is opposite over adjacent. So this problem can be solved by taking the inverse of both sides, which when I punch that in my calculator, inverse tangent of 17 divided by 11 is 57.1 degrees roughly. So that looks like D. So using tangent to find an angle there. Alright, moving right down, number 11. So Mia's sailing in a boat. What is the height of the airplane in yards? So the picture's drawn for me, so angle of elevation, kind of nice. So if I stand on the angle that's given, this would be opposite, this would be adjacent. This again looks like a tangent problem, except for I know that I'm standing on 25 degrees. I don't have the opposite. So looks like X is high, I gotta multiply. And punching that in my calculator, I'm getting about 35 yards. So moving right along, number 12. So first thing I noticed that's changed, well, one, I'm on a new page, but the other thing that I've noticed that's changed is this is not a right triangle. So when it's not a right triangle, you pretty much have two options. You have the law of sines or the law of cosines. One of those two laws. And it depends on what I'm given. Instead of trying to memorize what you're given, I would try to always set up the law of sines if possible. So basically they want us to find the length of AC. AC is this side right over here, which is across from big B. So I'm going to call it little b. That's just kind of a way that we label the sides based on the angle they're across from with the lowercase letter. Now I try to set up a proportion, and as long as I have 3 out of the 4 pieces that I know, I'm okay. So I think I can use the law of sines here. This is the sine of 62 degrees over B equals the sine of 30 degrees over little a, which is over here, which is 13. So now I'm basically going to cross multiply. I have B times the sine of 30 degrees equals 13 times the sine of 62 degrees. And ultimately, I wanted to find out what b is. So in order to get b by himself, the opposite of times by sine of 30 is divide by the sine of 30, divide by the sine of 30. And I can calculate that, put that all in my calculator. And when I did that, I believe that I got C, 23. And then I kind of want to use my BS meter and just make sure that that looks like it could be feasible. And it looks like it could work because it is across from a pretty big angle. 13 was across from a small angle. So on the surface, it looks like it could work. All right, moving on down. This is what I was talking about where they don't really want the answer, but they ask which equation could you use for angle A. So if I wanted angle A, what equation could I use? Well, there is no way to set up the law of sines because when I go across, I'm missing the angle, I'm missing the angle, I'm missing the angle. I have to at least have one pair that match up. So the law of sines is out. I'm going to have to do the law of cosines. Now, if I want to find angle A, I need to use the A equation. You know, little a squared equals, and before I finish it, I always know that whatever letter is in the beginning has to be the same letter at the end, but one's the side and one's the angles. The other two letters go inside here in this format. And so now I just got to see which equation matches up with that. Well, little c is here, little a is here, and little b is here. So I need to start off with little a squared. So the right equation should start off with 18 squared. And I believe this one right here is going to do it for me. That's going to find angle A. So you didn't even have to work it out. All right, number 14, moving on down. Here's one we do have to work out. Find the length of AC. So again, I try to play the across from game. Well, I don't have both B's, I don't have both C's, and I don't have both A's. So that right there tells me I cannot use the law of sines. I got to use the law of cosines. So let's label my sides. Little a, little c, and little b is what we're looking for. It says find the length of AC, so aka we need to find little b. So let's use the b equation. B squared equals a squared plus c squared minus 2 times a times c, all times the cosine of b, and I do have big B. Big B is 91 degrees. So I'm going to jam all that into my calculator. I'm going to multiply all that out, and I believe I got 1089.6. 1089.6, which that's way too big for a side, but I do remember, oh yeah, I got to take the square root of both sides. So when I take the square root of both sides, the square root of 1089.6 is roughly, if I can punch the right keys in here, about 33. So correct answer there is B. Now 15 was rather challenging. 15 is kind of tough. And again, this is a question that we saw on a standardized test, so we thought we would ask this one and present it in a way where you're not really solving, but you're showing you know how it works. So which set of information could I use the law of sines? All right. Well, one way that could help you is the law of sines is used when you have angle, angle, side, angle, or ASS. All right, those are the three ways you could use law of sines. Now, even if you don't want to remember that, just kind of jot down the information and see if it could work. So like number one, and I would write really lightly with my pencil, but if you had 108 degrees here, you had 33 degrees here, and you had 39 degrees here, I could not use the law of sines because I don't have any of the sides that I need. Okay, I'm missing all of these. So I couldn't use the law of sines for part A. So then I come back through and I look at it again, part B. If RS was 5, ST was 11, and angle T is 41 degrees, well, this one, let's see, I have these two, but to get x, I would need to have the angle across from it, and I don't have it. I would have two unknowns. So definitely cannot be B. Let's try C. When RS is 7, ST is 13, and the measure of angle S is 41 degrees, and I try this one, well, here's a pair, but then again, I don't have angle R and I don't have angle T, and I'm screwed. Now, hopefully part D here works, or I made a mistake somewhere. So let's double check D out. If ST is 8, measure of angle R is 102 degrees, and S is 37 degrees. Now I think I'm in business. I have a pair. You know, I could do the sine of 102 over 8, and then I go this way and I have the sine of 37 over x, and notice that I do have three pieces that I know, one that I don't know, so this could definitely be used for the law of sines. Alright, so that one was a little tricky, presented a little bit different. Alright, now we're getting into the short answer, free response questions. Expect a couple of these on the test. You're traveling underwater in a submarine, so let's just kind of put our little submarine right here. The sonar system detects an iceberg 4,000 meters straight ahead with an angle of depression of 34 degrees to the bottom of the iceberg. So angle of depression, so from my view right here, all right, coming down, I see the bottom of this, you know, there's this huge gigantic iceberg over here, and the angle of depression is 34 degrees, and I need to know how many meters do I have to go lower to get under it. So basically I'm trying to figure out this right here. I'm trying to figure out x, and it says the iceberg detects the iceberg 4,000 meters straight ahead, so 4,000 is right here. So there's my triangle. I believe that I can use tangent for this problem. This should be my 90 degrees angle. So this would be opposite the 34 degrees. This would be the adjacent. So the tangent at 34 degrees is the opposite over the adjacent. And when x is high, you multiply. So 4,000 times the tangent of 34 degrees comes out to be roughly, what did I get on this one? I got about 2698. 2,698 feet is how much lower I got to go to get under that thing so I don't ram it. So luckily it was a right triangle. I could use SOHCAHTOA. So number 2 says, hey, from the question above, once you get underneath that iceberg, you then pick up another issue. All right, so I'm back here in my little submarine. Beautiful artwork there. A sunken ship straight ahead. So there's a big old, you know, sunken ship down here, straight ahead. And that's a horrible sunken ship, but whatever. It says it's 1,500 meters straight ahead. So from here to here, that's 1,500 meters. Angle of elevation to, and why don't I just get rid of that little flag? That's kind of bothering me. So I need to go up at an angle of elevation of 19 degrees, all right, to the highest part of the ship. So basically, how many meters must I rise? So again, I'm trying to find this piece right over here. We're going to call that x. So how high do I got to go to get above it? So this is also a tangent problem. So the tangent when standing at 19 degrees is opposite over adjacent, and multiply by 1,500 to both sides. And that one shakes out to be, I got 516.49. So 516.49 meters. So not too bad. Now number three is the rough one. Number 3 is no joke. So let's kind of get after number 3 here. So it says a river cuts through a state park. So let's kind of draw this. We got a river cutting through a state park. It says visitors can cross back and forth using paddle boats. There are 2 paddle boat docks, A and B, positioned directly across from each other. So I'm going to put paddle boat A, paddle boat dock B, directly across from each other. So, on the same side as dock B, there's a shelter house that sits next to dock B and a distance back from the edge of the water. So there's some sort of shelter house over here. I'm going to put SH for shelter house. Maybe, and I will also kind of think of that as C, just because I'm doing A, B, and C. So that's there. And a surveyor wants to determine the width of the river between the 2 docks. So here's my triangle. And we want to find the width of the river, so that's what I'm after. The surveyor found the distance from dock A to B, or from B to the shelter house, is 84 feet. So from B to the shelter house is 84. Standing at the shelter house, so when you stand here, it says the angle between docks A and B is 34 degrees. So this is 34 degrees. Standing at dock B, so if the surveyor moves to here and he sweeps the angle from A to C, it says this is 110. I had to pause that. Alright, jump back into the mix. So now when I'm trying to solve this, I would like to use the law of sines if I can, and I think I'm able to because I have angle, side in between, angle. But when I try to set it up, I have a bit of a problem. So I see that I have this pair. I have the sine of 34 degrees over C. But then I'm missing what's across from 84. But I can actually calculate that because when I look at it, I have 110 and 34 is 144 degrees. Subtract from 180. That's going to give me 36. So I actually know what angle A is. It's 36 degrees. So I'm going to go ahead and finish this. Sine of 36 degrees over 84. And I do a little bit of cross multiplying here. 84 times the sine of 34 degrees equals C times the sine of 36. Divide both sides by 36. And that should tell me what C is. And let me punch this in my calculator. 84 times the sine of 34 equals, divided by sine of 36 is 79.9. So about 80 would be how far it is across from the river. Now that makes a lot of sense because across from 34 and across from 36 should be very similar to each other. And they are. They're very close. So I feel pretty good about that answer. All right, well, hopefully you're ready to rock and roll and do very well on the test tomorrow. See ya.